Welcome to the Stormsurf video surf forecast for the week starting Sunday, August 3rd. Brought to you by Vunabaka.com, a new surf and ocean-based residential community in the island of Fiji. Check them out at Vunabaka.com. We have a lot to cover, so we're going to move fast. First, North Pacific. 3 tropical systems. Hurricane Iselle, east of Hawaii. Tropical depression, Genevieve, south of Hawaii. And Super Typhoon Halong, south of Japan. Watch these as we put them in motion. Genevieve and Iselle continue pushing generally east, Halong to the north, still maintaining good strength. Notice Iselle taking a track projected towards the Big Island, and yet another system is forecast behind that, at least as strong as Iselle, if not more so, Halong continuing north. Genevieve, meanwhile, starts developing come Thursday. They continue on their path with Halong basically brushing, if not moving, right over central Japan. Notice Iselle actually pushing north of Oahu, and the next system, unnamed at this time, building, while Genevieve also builds. 4 systems projected, plus, notice this, yet the remnants of another tropical system that did the whole curve across over the Aleutians starting to develop in the northern Gulf of Alaska. All this in effectively the first week of August. This is a good sign. They continue on their way, and we're into about Saturday. So Iselle starts fading out. Halong basically moves inland, but Genevieve building rather dramatically, along with the new unnamed system, if you can believe it. We're out here now 180 hours. The new system has actually had paths moving into or near the Hawaiian Islands. The latest run, at least per the GFS model, has it south. Notice remnants up here heading north. This system developing, well, better yet, let's just go take a look at this. Experimental long-range forecasts. Iselle recurving north. Some members suggesting up into the Gulf of Alaska at H1 Hurricane 1 status. Others say H2 status. Others say it dies early. Unknown. Genevieve building to supposedly Cat 4, if one's going to believe it, and heading north. And of course, Halong fading out some, but still very strong, Cat 4 through the Sea of Japan. All this, of course, is completely unbelievable, 180 plus hours out, but the trend is very good in that there's 3 systems, all of them taking some sort of a northward track, and we're not even into the heart of the hurricane season yet. So this is all good news for the North Pacific. Next, we go down south. Small gale, southeast Pacific, 28-foot seas barely, aimed well to the north, and another system developing under South Australia, and we'll just go ahead and give it up some now. There is some suggestion this part, the southwest Pacific, is going to become active. Let's go take a look at the details. First, the usual jet stream analysis. 250 millibar winds. These are winds up at the jet stream level, 30,000 feet or above. These winds help direct the track of storms when they form, and also help promote their formation when you get a trough, a bend to the north. Right now, generally, there's a ridging pattern. Notice this, the jet stream is just plowing into Antarctica, shutting down development in this area. Though notice, this is actually what you would call a cutoff trough. The main energy is flowing into Antarctica, but there's this little trough here, and we noticed on the wave model chart there is a small gale of some sort trying to organize here, 26, 28-foot seas and aimed well north. Here, just basically, it looks like a zonal flow setting up. We'll just put this into motion. And you notice as we go into time here, basically a more or less flat west to east flow. But then we see some wind energy starting to build here under New Zealand come Tuesday. What was that? About 110, 120 knot winds, and here we go, a bit of a trough starting to organize. This would promote clockwise circulation down at the surface. Not a lot of good wind pushing up into this trough, though. Maybe some support for gale development. And then we go back into the sort of the zonal flow into Sunday, and then we get yet a stronger trough with 120 knot winds building under New Zealand, and that should help formation as well, and that goes out 180 hours, and that's the end of it. But a big ridge starts building here over the central Pacific. So this area looks the most promising. Let's go look down at the surface. This is surface level winds, surface level pressure. 1032 millibar high. That's high pressure in this area. Notice low pressure under Tahiti. This will support a negative drop in the Southern Oscillation Index, the difference in pressure between Tahiti and Darwin, Australia. Low pressure in this area tends to get you negative numbers. The more low pressure in this area, that suggests that you have westerly wind bursts, low pressure generally along the equator, and that is the key sign in the development of El Nino. At this point, that is not so much an issue, and let's focus on the task at hand. Low pressure under New Zealand, 35, 40, 45 knot winds in pieces, moving generally to the east. Not a super well-organized fetch, but there's one there, and notice the swell vectors all pointing well to the south. Another one forming under New Zealand, supposedly on Monday, 55 knot winds holding together well and moving east. And notice, even 50 knot winds into Tuesday, but the general track of this is southeast rather than northeast, and we'll see what the issue is with that in relation to the Great Circle paths in a minute. All that driven by high pressure right here, pushing everything to the south. And yet another system on Wednesday developing. There we go, pretty broad system, 40, 45 knot winds, but most of it looks like it's to be impacting New Zealand, a little bit down below. Still, potential for swell, and yet another system. We're 108 hours out here under the Tasman Sea. It sort of fades out, and we keep going here. There should be one more. There it is as of about Monday. So potential in this area. Not seeing a whole lot going on here. Notice 1024 millibar high with isobars reaching the whole way over. Antarctic ice is somewhere down around 62, 63 in this region. So basically the storm track is over Antarctica in this region. So the Southwest Pacific will be the focus. Next, significant wave heights for the South Pacific Ocean. Also notice the tropical activity in the northern hemisphere. But of interest, we're actually going back to Saturday here. Small gale developing, was that 24-foot seas on Saturday, and we'll just sort of roll this out. Notice it's pushing north, and 26, barely 28-foot seas there were current. Let's look at the Great Circle paths relative to Southern California. That's about the 181-degree path. And Northern California, it's out in about the 178-degree path. So only those with the most southern exposure would see anything from this one. But notice, the storm itself, or the gale, I guess, is actually moving to the north, which means swell should be pushing into this region, though the reality is most of the energy would be either there, Costa Rica, or Peru. All right, let's keep going. That fades out. New activity building under the Tasman Sea, 32-foot seas. Pretty strong system here, 42-foot seas as of Monday night. And actually that is, no, not quite, barely. The southern tip of it's barely in the northern Cal swell window, but this should be in the southern Cal just barely also, and not in the Tahiti swell shadow. So that's 6 hours or so, but notice it fades and starts falling south. I'm just looking at the Great Circle paths here and moving into the shadow as well pretty quickly. What you want is the storm to go up this way, and here we'll show it. So here, like between here and here is where you want the storm to not be shadowed. What is that? It's about 213 or so. And if it's traveling up in this corridor, literally you can draw a box right here. And if the storm is traveling up in there, you have unshadowed southwest swell. But if it's going southeast, you don't have as much energy pushing north for one, and two, it gets shadowed a lot easier. Anyway, at least a little something, some energy should result. Another system, we're into Wednesday night and Thursday. Most of it ends up over top of New Zealand. Not so interesting. And then there's yet one more coming on. Here we go into Sunday. Now, if you believe the model's a week out, that's not such a good deal. But into Sunday. But it's a start. At least there's some activity here. So there's a little bit of potential southern hemi push. But the reality is, if any of these systems in the northern hemi recurve north and develop, you'll get way more swell north of Point Conception, and whatever happens down here will almost be a moot point. So, potential, both north and south, that's exactly what we want to see for this time of year. And a case in point before we get into the Southern Oscillation and long-term numbers here is that typically you will not see tropical swell or recurved tropical swells arriving in California before August 15th. I mean, historically that's sort of been the timeline, the earliest we've seen anything actually arrive like a recurved tropical system, not pure tropical, but really what you'd call extratropical. Anyway, onward, long-term. Southern Oscillation Index, difference in pressure between Darwin and Tahiti, minus 17.66, that's good. The 30-day running average, -2, basically neutral. Long-term average, effectively 0. So as of right now, and you're looking for, we want to see a long run of negative numbers. We're not seeing that. The actual 30-day average is rising. So right now we're basically at a neutral phase of the MJO all across the board. So let's go see what's going on. Surface level wind anomalies. These are winds direction and speed different from normal. We're looking for westerly anomalies, or preferably strong westerly anomalies, also known as a westerly wind burst. Here's Australia. Philippines are up here, and Japan up north. There's Taiwan. We're looking for westerly wind anomalies, let's say 5 degrees either south or north of the equator in this region. This is where Kelvin waves are generated. We see basically weak easterly anomalies, but good westerly anomalies here on the date line. Let's go to the east. Also notice here's those westerly anomalies, and they continue almost to a point, well east of Hawaii, which is pretty good for this time of year and exactly what we'd want to see. Westerly winds help create Kelvin waves, and Kelvin waves fuel warm water buildup off the Galapagos, which in turn is the hallmark of El Nino. Looking a week out, the winds are supposed to turn easterly. Not a good sign, but to a rather small area here around 160 east. Again, we're in the West Pacific. And then looking further to the east, a week out, basically a neutral pattern of no particular interest. But note, these winds are at the 850 millibar level. What really matters is winds down at the surface, and there's only one way to see that. That's with the TOA, or more correctly said, the towel array. Anyway, here is surface temperature and wind anomalies. And notice here, suggesting westerly anomalies, and this has been the case since late June. There's been some flavor of light westerly winds persistently blowing in this region, you know, from 150 east to maybe right around the date line or so, a little bit over, and that's good news. And it doesn't take much. Even neutral anomalies will do it, but preferably a light westerly wind anomaly, and we'll see more about that in just a second. So where are we going from here? The 2-week models suggest the orange and yellows are the inactive phase of the MJO. Lots of good reflectivity off the ocean surface, suggesting no clouds, which suggests the inactive phase, of course, the MJO. So the statistic model suggests the inactive phase. The dynamic model is now suggesting it as well. So that's not what we would want to see. The question is, are these models right? We also go take a look at the long-term upper level model. This has, for couple of weeks now, been suggesting all through the month of August a very strong inactive phase of the MJO working its way across the equatorial Pacific. But as of the past week or so, it's getting steadily weaker and steadily weaker, which has been the trend with this model all along. It did the same thing in July. Said massive inactive phase. What do we end up with? A neutral phase bordering on light active. And here we go again. So we'll say this is the worst case scenario. Light inactive phase going through, maybe the 23rd of the month, going into effectively a neutral phase. If we were in El Nino, it would be basically dead neutral. No MJO going on. If anything, maybe just lightly active. And we suspect that's exactly how this month's going to play out too, just like July. And that would be good news. Next, let's take a look at sea surface temperature anomalies. And this is where things get kind of interesting in the bad way. Notice warm anomalies here, and it's really in the equator that we're interested in. Light warm anomalies here, basically half a degree or so, maybe up to 1 degree. Here is the warm water that's been building up from the last series of Kelvin waves that westerly wind bursts that occurred January, February, March, April. And like we said before, massive Kelvin wave developed. We expected a large amount of warm water to build up here. It has, and it's holding pretty good right now. But notice, cool water there, there, especially. This is the Nino 3.4 region between 120 and about 170. It's all cooler than normal now. Certainly looks like El Nino is completely falling apart, and that's what we've been thinking for a while here too. But we have another theory, and we'll talk more about that in a minute. The other thing you notice is massive amounts of warm water buildup. I mean, everywhere north of the equator, it's warmer than normal. Local water temperatures, Southern California, Northern California, way above normal. And it's not just a local sort of anomaly. This goes out thousands of miles. There is a lot of heat energy in the ocean, and that is going to be imparted into the atmosphere one way or another. It's just not going to disappear. Notice a couple little splotches here of cooler water. Normally, the Gulf of Alaska has high pressure here in the spring, makes piles of north winds, drops water temperatures, and for 3 years now, there's been like a cool pool just sitting right here because the high pressure has just been pumping like mad. Well, what happens during El Nino is this high becomes suppressed and water temperatures start warming, and that's what makes the warming along the coast, and that is clearly what's happened. Even this spring, there was no effective, real warm water push. We believe that was a teleconnection associated with the change, the westerly wind bursts that were going on here, and it's still going on, and there's no sign of it breaking up. So that is good news. That's a suggestion that something more than just this little localized westerly wind burst thing that's going on here is happening, but there's also something happening up in the Gulf of Alaska. The warm water is also resulting in the hurricane activity we're seeing. Multiple storms running along here, south of Hawaii, in the West Pacific, and what we would really want to start seeing is those systems recurving north, getting caught in the jet stream and tracking back towards the Gulf of Alaska. You would perhaps expect to see a significant storm perhaps as early as mid to later September if that were the case. Way too early yet for that to be happening, but just the sheer volume of activity in the tropics at this point in time is a good sign. It's a testament to the heating, and it's a testament to lack of shear in this region, which supports the formation of tropical systems. Of course, the big issue is this persistent cool pool that's been blowing related to, I guess you'd call them trades pushing off of Chile. That's still the case. We do not believe that these trades are directly related to this cool pool here, and we'll get into that more here in a second. Here's a quick look at the current high-res sea surface temperature anomalies off of Peru and Ecuador. Things are not looking good. I mean, there's just not as much warm water as there was here. There was anomalies up to 4 degrees. We're below that threshold now in this pocket, and it's shrinking. Cool anomalies developing here. All this suggests that the warm pool is in decline, and that is actually not unexpected. We knew that the Kelvin wave was coming. We could time when it was going to erupt. It did pretty much as it did. We knew when it was going to die because we knew when westerly winds started dying off over on the dateline, and the expectation was that this would start fading right about by 8/1, and we're at that date, and that's exactly what's going on. But there's a silver lining in this cloud. Subsurface temperature anomalies, absolute water temperatures, and anomalies from normal, and this is what we're really interested. So notice, if you recall, there was massive warm water buildup in this area 2 months ago, 5.5 degrees above normal. Now all of a sudden it's cooler than normal, and this water was actually coming from over here, and as the cooler anomalies are working their way this way. But of more interest, as of just today, confirmed now, 2-degree anomalies above normal. New Kelvin wave developing. This is the dateline here. This is the Kelvin wave that is the result of what we'd call very light westerly anomalies that have been blowing June and more like late June, mostly July. So another Kelvin wave appears to be on the way and migrating this way. The question is, can it push this cool water out of the way? We believe it absolutely will. In fact, the cool water anomalies that we're seeing gurgling up off Peru are the result of this, and it's also the result of the advection of this water over the surface into the Nino 3.4 region. Here's another version of that. Here's the new Kelvin wave. This one's actually, this image from July 27th, so it's a little older, still shows pockets of warm water. But here's the cool water, and that's coming in, going to replace this warm water. And we're going to see temperatures collapse off of Ecuador, probably into negative anomalies. The question is, how large of an area will they spread out and fan out once these cool waters reach the surface? We're not particularly sure, but we're thinking it's going to be a rather limited event. At least that's the hope. So let's put things in historical perspective. This is the upper ocean heat anomalies, that is temperature difference from normal, and I believe this is from 300 meters up, okay? And here's over time. So August, September time frame, notice and here is the date line here, and here is the coast of Ecuador here. And so what you can actually see is the migration of Kelvin waves working their way east over time. One tiny Kelvin wave, we saw it back the fall of last year, but paid not much attention to it because it was weak. Followed by, notice, a small bit of cooler water. Followed by yet a stronger Kelvin wave that started in October in the Far East, made its way the whole way across into January, followed by what? Another area of yet stronger cooler water. So it appears that the amount of cool water is proportional to the Kelvin wave that preceded it, followed by the massive Kelvin wave that was developed in January, February, March time frame and migrated east and erupted along the Ecuador coast, followed by yet another area of cool water, and a substantial one, okay? And the suspicion is that the westerly winds also faded out over the dateline when these cool pockets occurred. One could easily go, oh, it's just the MJO, but if you're not looking at depth and looking at this chart, you wouldn't really see the pattern that's going on. And notice here we are in July, the start of the new Kelvin wave building, and we know now that it is up to 2-degree anomalies, and it is pushing east. So the thought is, so these are what they call the downwelling phase of the Kelvin wave, and these cooler interludes in between are the upwelling phase. We believe, again, theory only, won't confirm it till you know it, but that the cool water that is building over the Galapagos right now and showing up in the Nino 3.4 region is actually just the upwelling phase of this previous Kelvin wave, and that it will be replaced by yet another Kelvin wave and more warm water over time. The question is, how much warm water? How large is this Kelvin wave going to get? How much westerly wind anomalies are in the future? None of this we know. If basically it turns out there's not a lot of west wind anomalies and this Kelvin wave's a wimp, then that'll sort of doom our El Nino, because El Nino is totally dependent on warm water in the Nino 3.4 region, and most of that actually advects over from the Nino 1.2 region. So right now we're at do or die time. This warm water here, we're waiting to see what happens. The other thing though is typically in the fall is when you get the big westerly wind bursts. A lot of them are associated with tropical systems that form in the West Pacific. So, and as you can see by the charts, there's piles of tropical activity going on. So the suspicion is the tropical feature of this developing El Nino, if it's going to happen, should blow up here in the next month to 2 months. And when it does that, that'll create westerly wind bursts, start the warm water pump, and maybe we'll see some more, either a prolonged Kelvin wave, probably not of this magnitude, but a decent solid Kelvin wave. It takes 3 months to make the journey. So if it happened, let's say the beginning of October, then you're in October, November, December-ish time frame, that would be perfect for El Nino. So we've really got 2 months for a substantial Kelvin wave just to develop on the dateline, and then it still has to make the journey over here. But with all the warm water that's already present in the northern hemisphere, the suspicion is there is some coupling already going on, and that's being evidenced by the amount of tropical activity that's going on, the projections that these systems are recurving. You know, you got to see it happen, though, but the models are looking very encouraging at this point in time. Maybe not a huge El Nino, but a moderate one. And finally, JSON-2 data suggesting these are sea heights. That is, if the ocean surface is higher than normal, just the average ocean surface, then it suggests heat at depth. There is heat at depth over the in the dateline region here on the equator. As we now know, there is a Kelvin wave there, and it's making its way east. There is nothing here which suggests water temperatures will collapse in this region, which is the signature of El Nino. But not unexpected. The thought is this is the upwelling phase of the Kelvin wave. We're not going to lose too much sleep over it. The issue is the 97-98 El Nino had literally no upwelling phase. It was just one massive Kelvin wave. If you build your model for this year's El Nino based on that, you're going to be disappointed. And we had done that. We were thinking, oh, this is going to be like the 97 El Nino because of the huge Kelvin wave that happened earlier this year. But that's not the case. It was a strong start. It's kind of sputtered, but we don't believe it's out. We believe, given all the other signals, more activity is coming. We'll have some sort of an El Nino event, and it doesn't have to be a strong one. We don't need a strong one because there's downfalls to that too. And finally, the CFSV2 version El Nino model, whatever you want to call it, water temperatures, monthly temperatures for the Nino 3.4 region shows 1 degree anomalies in October, pushing up to about 1.45 in the December time frame, which would be this would be a typical El Nino, similar to the maybe the 2009-2010 El Nino, which was a pretty good El Nino. We had pretty good surf. It wasn't completely off the charts. It wasn't psycho, but it was solid and respectable. This one, if you believe the models, would be in that sort of category. And here's the latest water temperature forecast. If you can see it, it actually depicts here the cool spot developing in August associated with the upwelling Kelvin wave phase, and warm water building here over the dateline exactly as we are into September. Things try to start recovering, but notice the warm water really starts building here more purely in the Nino 3.4 region. The Nino 1.2 isn't even hardly in play. And then you get into, here we go, we'll just drag this whole thing down. There we go. We get down into October. Basically the same sort of thing, and then you go up into, here we are in November, warming starts building. Notice the Nino 1.2 region isn't even in play, and more so in December, and then finally peaking in the January time frame, and these are about 2 degree anomalies, 1.5 to 2. So that's, this is all from the same model, just in different variations. But the interesting part is, if this is true, the warming is more to be sort of in line with what was believed to be the pattern for the 82-83 El Nino. Not as strong, whereas the 97 Super El Nino was, it was just huge in that it covered all of Nino 1.2 the whole way over to the dateline and beyond. This is sort of more of a moderate, and in this region, still good, respectable, and maybe if we get lucky, even if it's weaker, that would be even better in that it might go and spread out to be a multi-year event. Probably not, given this is what actually develops. But if the next Kelvin wave doesn't develop as strong and the whole thing kind of sputters, then maybe we won't have lost enough heat energy in the Pacific, and maybe this will string out to be a multi-year event, which would be even better. But suspect that's probably not going to be the case. So we've covered a lot of ground here, but the quick synopsis is tropics are very active in the North Pacific. Southern Hemi is trying to come online slightly, but it's kind of late and kind of weak still. And there's actually, we didn't even talk about it, but there's small swell in the water right now working its way towards California for the later part of the week. Nothing huge, but at least there is some swell coming. So, and of course the El Nino thing, we kind of went through that. It looks like there's hope if one believes in the upwelling, downwelling Kelvin waves theory. That would suggest that more is to come. There certainly is another Kelvin wave developing right now, and westerly winds are occurring. Nothing strong, but a little bit. So the outlook short term is, if we can just get through the next month, we're in pretty good shape in terms of just being over the hump. There's plenty of warm water. We expect the winter pattern to, to be reasonably decent with the tropical activity that's going on. If it keeps up even half of what it is right now, the odds for a recurving tropical storm into the Gulf of Alaska is good, and that in and of itself can make great surf. So I think we're starting to turn the corner, which is finally good news for the skeptics among us, myself being one of them. That is, we'd rather remain skeptical and not be disappointed than overhype something and then get disappointed continually. So we tend to sort of err on the conservative side here just to keep everything in check. Anyway, many thanks to Vunabaka.com. Check out their website. They've made tremendous progress on the construction of the new site in Fiji. They're working on the harbor right now, and lots around the harbor, and it's really quite an impressive project. So check it out, Vunabaka.com. And thanks a lot for visiting and watching the video. We'll do this again next week, same time, same channel. Thank you.